Okay, how to apply average, unit rate, and range, sometimes also called volatility, in this math riddle. So I found this math riddle. It says it takes 6 cats 6 minutes to catch 6 rats. How long does it take 100 cats to catch 50 rats? Well, at first glance, this really does seem like a unit rate question, where you might just say, okay, well, 6 cats as a ratio to, here's cats to rats to minutes, 6, which is the equivalent of 1 to 1 to 1. So you may think, oh, okay, if this is if this is the average, it takes 1 cat 1 minute to catch 1 rat. Then when we apply it to 100 cats, okay, and there being only 50 rats, the idea is that this is half of that time. So what would half of the time? This is half the amount of rats. So assuming that adding a cat cuts the time in half, then the idea then becomes it becomes 50 minutes, essentially half of 100. Okay. I'm not going to go into much detail about this because I actually really want to address the assumptions in this question. So the first thing I want to talk about is I'm going to kind of box this off here as a first glance question. How are the cats released? And this is really a question about like averages and how this is being done. So here's the question. Here's my lovely rendition of some cats. Okay. Here's a cat. Laughing at my own picture of a cat. I'm going to duplicate this. Doesn't look like it. I'll keep drawing. Okay, so we got our 6 cats. 2, 3, 4, 5, 6. I'll do my best to draw all these nice cats here. With their nice tails. And I want to talk to you about this. So, what do we think is happening at this point? Or do we think that the cats are being released every single minute? And then at the end of a minute, a next cat is sent off. So the idea to this is, okay, so here comes the 1 rat. And this is minute 1. So 1 minute. And the cat goes and catches it, and check, he gets the rat. And now once that minute's done, the next cat goes. And it takes that cat roughly a minute to go and catch that rat. And then it's done. And then so on and so forth. And we end up with 6 minutes. That means we're releasing 1 at a time. That is a potential scenario. And again, this 1 minute is an average. I mean, it could actually take, let's shrink this a little. It could take the first cat, 10 seconds. And then this cat, 10 seconds, 10 seconds, 10 seconds, 10 seconds. It's 1, 2, 3, 4, 5. So that's 50 seconds. And maybe it takes the last cat 5 minutes and 10 seconds to catch it, which ends up equating to 6 minutes. And if we were to average this all out, this ends up actually being 310 seconds. If we were to actually find an average of all this, we're looking at 10, 20, 30, 40, 50 plus 310 is 360 seconds divided by 6, because there are 6 cats, which equals 60 seconds. And that's your 1 minute average. Okay, so that's where we get the 1 minute average. Except that, isn't that a really weird way to release cats to catch something? Doesn't it make much more sense to say we release all these cats right away and they chase down the 6 mice? Rats, I should say. My drawings are just getting worse and worse here, but that's okay. The idea is to get the concept. There's 2, 3, 4, 5, 6. Some are far bigger than others, and apparently they have no tails and feet, but that's okay. Here we go. And okay, so we release them all. And doesn't it make more sense that they all get released at the same time, right? They get released. And then maybe, 1 rat gets caught, and then another, and another, and another, and another. And finally, at the 6 minute mark, finally the last rat is caught. Well, if that's the case, and maybe it's 1 cat per rat, it took this 1 cat, actually took 6 minutes to catch a rat. Okay? And if it took that one cat 6 minutes, and that's like the weakest link, let's say, of all the cats, and the rest of them were less than 6 minutes, it still took this cat 6 minutes. So they are the timekeeper for this entire thing. In fact, it could have took all the cats 6 minutes to catch them. All we know is it said it took 6 minutes to catch 6 rats. We don't know if any of them caught them faster, but for sure the last one took at least 6 minutes. So if the last one took 6 minutes, okay, and maybe adding more cats to the mix doesn't make a difference, let's make that assumption. Let's say adding cats that doesn't make a difference. Well, then if we have 100 rats, so here's all of our rats, I'm just going to dot my way through it, and then we have all of our cats, they'll be our circles in this case. Maybe I should color code it. If there is a cat for every rat, and remember it said 50, I'm going to say there's 100 at this point, okay? So we're going to say here's the 100 rats. I didn't mean to change that. And here's 100 cats. Well, if they're doing the exact same thing as we stated they would above, and let's say that this is the absolute slowest cat, this one that took 6 minutes, well, it's also going to take 6 minutes for these 100 cats to catch all of these rats. You see that it's not an average thing. It's actually the concept of how slow the slowest cat is. And if the slowest cat takes 6 minutes, and it only takes 6 minutes because we're on a 1-to-1 ratio. Now, it is very possible that adding or cutting the number of rats and putting them down to 50, okay, let's say we turn them into 50, so we have 50 rats. So now I'll put a couple dots here, and we have 2 cats for each of those rats. Well, maybe... I'm doing it justice here. Here we go. We have 2 cats at each one. Maybe that cuts the time down in half, but it's very possible the cat gets in the way, and again, it still ends up being 6 minutes for the catch it. If by chance adding 2 cats per rat cuts the time in half, we would just take our 6 divided by 2, and then it's 3 minutes for 100 cats to catch 100 rats. So this 50-minute thing, that our first number that we came up with in terms of a ratio, that is actually very improbable. Unless it is this scenario here, and we'll call it, scenario 1, where we release 1 cat after it catches a rat, depending how long it takes, and we know that the average is 1 minute, then we can assume that on average it would take 50. But here in this scenario, we're talking about range and how long it takes a cat. And maybe one cat caught 1 rat in 1 second, but the last cat took 6 minutes. And 6 minutes is your 360 seconds, okay? And that here talks about range. And this is where the range is really important, the volatility of this. It's that last time that's extremely important. It's like saying we're going to run a race, and whoever's the slowest runner is going to be your team's time. It doesn't matter who the fastest runner is. It's all about this last time here. So that last cat took 6 minutes, which is 360 seconds. Okay? So because that's the case, then we know that's the weakest link. That's the high point of the range. And when we apply that range to this scenario, we call it maybe scenario 2, we know it's going to take 6 minutes because that is our slowest rat catcher, that mouse. And let's go to scenario 3 down here. It's possible that doubling the number of cats might split the time in half, or it's possible they just get in each other's way and it still takes 6 minutes to catch all of those rats. So it's a very ambiguous question because there's so many different scenarios here. But I'm going to go on a limb here and say that it makes much more sense to consider scenario 2 that we did in red, this one below, or scenario 3. Really, scenario 1 just seems extremely odd. The amount of control you need over the cats and rats to let one go at a time, it just doesn't seem to make any sense. So I'm going to say that it is taken between, my final answer here to this question, is it's going to take approximately 3 to 6 minutes for 100 cats to catch 50 rats. Okay? And I hope we kind of touched on the concept of averages, and the unit rate was that scenario 1 here. The range, which was really important for figuring out this part. And this was a neat little riddle that we found.